Imagine a future ocean where the surface gleams under a golden haze, not with the vibrant blues we once knew, but with an eerie tint signaling something ominous beneath. The peaceful waves ripple softly, hiding the silent, invisible menace of methane gas bubbling up from the seabed. Methane, this simple molecule, colorless and odorless, has become a ghostly architect of transformation. It seeps from deep cracks and decomposing organic matter, forming immense underwater mists that shift within the ocean's depths. What if these gas clouds are not just the remnants of decay but the crucibles for an unknown new life? Could these toxic bubbles, once feared as harbingers of doom, actually nurture strange, resilient organisms that thrive where oxygen fails? The stage is set for a world where life adapts beyond our wildest comprehension, flourishing in conditions that seem utterly inhospitable. Beneath the luster of the surfacing bubbles lies a landscape in constant flux, an ocean floor no longer quiet and barren but alive with shifting methane blooms. These blooms appear as vast patches of shimmering water, thick with dissolved gas and microbial life. Unlike anything known from the oceans of today, these methane-saturated zones are pockets of alien chemistry where traditional oceanic life struggles to survive. Here, bioluminescent microorganisms cluster in eerie clouds, their faint green and blue lights pulsing like distant stars caught in a toxic fog. They subsist by converting methane into energy, a process that redefines the very concept of survival. It's a luminous underwater aurora, but born in the darkest recesses, where light barely infiltrates. How did life find such resilience in these ghostly gas springs? What mysteries lurk in these glowing methane gardens, whispering secrets of adaptation and transformation? As we dive deeper into these murky waters, the secrets become more complex and unsettling. Vast plumes of methane rise relentlessly like volcanic smoke, releasing their ancient chemical payloads into the surrounding fluid, altering its very chemistry. Colonies of bacteria form dense mats, shimmering with otherworldly colors and unusual textures, creating bizarre habitats around gas vents. These microbial communities are not mere survivors. They orchestrate a living architecture, molding the seafloor into strange towers and gelatinous networks that pulse with subtle life. Some creatures have evolved translucent skin that breathes methane directly, while symbiotic microbes convert toxic gases into sustenance in a dazzling symphony of chemical exchange. This is not nature as we know it. Here, intelligence and cooperation emerge from sheer chemical need, crafting a frontier where the boundaries between living things and their environment blur. What does this say about the future of life on Earth or perhaps beyond? The story turns darker as we explore the life forms lurking within the dense methane clouds. Predators here don't chase with jaws or claws but glide silently, sensing vibrations through electric fields. Their movements ghostly and ethereal. Ribbon-like hunters glide with an unnatural grace, their pale, semi-translucent bodies barely visible through swirling gas and bioluminescence. They filter methane-rich water, their prey microscopic beings oblivious to the impending danger. Evolution has rewritten the rules entirely. Eyes have vanished since light is scarce, and bones are replaced by flexible, gelatinous forms. The methane gas that suffocates most life here fuels an ecosystem of spectral hunters and cunning prey, an alien dance unfolding under the ocean's toxic veil. How would we recognize intelligence or sentience in such an environment, where survival has been mastered in silence and shadows? Rising from the depths, we reach the surface where the consequences of the methane blooms writhe with even more dramatic force. Here, toxic bubbles burst into the atmosphere, igniting tempestuous storms flickering with lightning that crackles like the planet itself is alive and angry. Amidst these volatile skies, plankton have adapted to harness this chaos, encasing themselves in reflective shells that trap fleeting sunlight and methane alike. The ocean's surface becomes a shimmering, fractured mirror, reflecting illusions of sky and sea intertwined in a hypnotizing dance. The atmosphere and ocean interact in a dangerous feedback loop, fueled by gas emissions and climate shifts, casting the planet into an endless cycle of turmoil and rebirth. Is this fiery spectacle a warning or an invitation? What futures will life sculpt from this volatile interplay? The relentless rise of methane blooms reshapes not just the ocean but the very chemistry of Earth's climate. This new ocean, vast and mysterious, thrives on poisonous gas clouds that warp the once familiar patterns of oxygen and warmth. The remaining pockets of oxygen-breathing life shrink, retreating to isolated refuges or adapting in ways that challenge every assumption about survival. Methane-fed ecosystems spread like living fogs, rewriting evolutionary scripts with every ascent of gas bubbles and every microbial flourish. As this world expands, it seems to echo an ancient truth. Life never dies. It only changes face, reshaping endlessly in response to the planet's evolving breath. But what stories lie hidden in the silent methane depths? Could these changes reveal clues about past extinctions and future transformations? Amidst the haunting beauty of this methane realm, a profound question lingers. What does it mean to breathe when the air and water are soaked in different chemistry? For creatures adapted to methane, oxygen may be a forgotten relic, a concept as distant as the stars above. Intelligence, if it arises here, might perceive the world through senses and forms utterly alien to us. Will our definitions of life and consciousness expand to include this strange new ocean? These questions stir both wonder and unease, as if peering through a cracked veil into a future where humanity may be little more than a shadow on a changing planet. What lessons await in the bioluminescent glow of the methane clouds, whispering stories of resilience, transformation, and the endless drive of life to persist? As the golden haze of the future ocean fades into darkness, the methane blooms continue their silent pulse beneath the waves, a living testament to the adaptability and mystery of life. This is a world where toxic gas becomes the breath of life, and the boundaries between survival and extinction blur into a spectral dance. Here, in the cold, glowing depths, the ocean breathes in a new rhythm, deep, slow, eerie. A rhythm that may one day tell the story of life's ultimate transformation. As the methane clouds drift and shimmer, they invite us to reconsider the delicate balance on which all living things depend. In this quiet mystery, the ancient ocean whispers a warning and a promise. That life, in all its forms, is a force beyond reckoning, forever evolving, forever haunting the edges of the known world. We plunge now into the murky midwaters where sunlight fades to a ghostly green and silver haze, pulling us deeper into the heart of the methane blooms. These vast layers of gas-soaked water hang like suspended fog banks, dense and suffocating to anything relying on oxygen's embrace. Normal fish dart away in panic, their gills gasping futilely against the invisible toxin that saturates every swirl. But within this lethal veil, something stirs, life that defies extinction's cold logic. Bioluminescent organisms flicker to life, clustering in hypnotic patterns around the rising methane plumes. Their glow pierces the gloom like submerged stars, pulsing with an otherworldly rhythm that hints at secrets long buried. What hidden alchemy allows these beings to thrive where death should reign supreme? Could this be the birthplace of an entirely new oceanic realm, forged in poison? Picture these methane blooms as colossal underwater weather systems, trapping gas in stratified clouds that shift lazily with subtle currents. Microbes dominate here, engineered by evolution to feast on methane as their sole fuel, oxidizing it into energy without a whisper of oxygen. They form drifting webs of light, ethereal lattices that expand and contract like breathing lungs in the dark. Some pulse blue, others emerald, creating an aurora that dances silently through the toxic soup. These aren't random sparks. They're symbiotic networks, where larger drifters host microbial gardens on their gelatinous skins. The water thickens with their presence, turning clear depths into a shimmering haze of life. How do they sense each other's glow in this lightless void? Do they communicate through these flashes, weaving a silent society in the shadows? Deeper into the bloom, the horror subtly unfolds as shapes emerge from the luminous fog. Jelly-like entities drift, their bodies bloated with gas pockets that buoy them effortlessly against gravity's pull. They filter methane directly through porous membranes, their innards glowing from chemical reactions that mimic fireflies in hell. Tiny predators nip at the edges, sparking defensive bursts of light that scatter like startled ghosts. The air or water feels heavy, pregnant with unseen threats lurking just beyond the bioluminescent veil. Evolution has sculpted these forms for survival's edge, abandoning solidity for fluidity in a world of constant flux. What drives such radical change, turning familiar seas into alien nurseries? Might we one day witness intelligences born from this eerie luminescence? The scale astounds. Blooms spanning kilometers, alive with trillions of these glowing sentinels. Bacteria mats undulate like vast carpets, trapping gas bubbles that nourish overlying colonies. Crustacean-like scavengers skitter across them, their exoskeletons faintly radiant from symbiotic passengers. Each pulse of light reveals a frenzy of feeding, a microscopic war played out in spectral silence. Oxygen breathers perish here, sinking as limp trophies to the victors below. Yet this death fuels the bloom's expansion, recycling decay into fresh methane feasts. Isn't it chilling how life pivots so ruthlessly from one chemistry to another? What if these clouds are harbingers, spreading to engulf the entire ocean? Suspense builds as a low rumble echoes through the water, vibrating the glowing webs into frenzy. Plumes intensify, belching more gas that feeds the frenzy, lights flaring brighter in response. Drifting predators descend, drawn by the chemical banquet, their forms silhouetted against the radiant chaos. The bloom contracts, then expands like a living organism breathing in the toxin. Questions swirl. Are these isolated pockets or the vanguard of a global shift? How long until the surface feels their insidious rise? The midwaters hold their breath, teeming with possibilities that blur the line between wonder and dread. In this suspended world, every flicker whispers of transformations yet to come. Emotional undercurrents pull at us, the awe of resilience mingled with horror at obsolescence. These bioluminescent hordes remind us of deep-sea vents today, where life clings without sun's grace. But amplified by future methane surges, they evolve faster, stranger, into clouds that migrate like herds. Imagine swimming through them. Cool gas prickling skin, lights caressing eyes in hypnotic waves. They evade detection, invisible to sonar, masters of stealth in their domain. What evolutionary pressures birthed such cunning? Could humanity's legacy be this glowing testament to unintended creation? The mystery deepens, urging us onward into darker truths. As the bloom's lights fade into deeper gloom, a profound unease settles. These organisms don't just survive. They dominate, reshaping water chemistry in their image. Symbioses tighten, blurring individual boundaries into collective glows that span horizons. Thought-provoking. If light is their language, what tales do they tell of our warming world? Mild horror creeps in at the thought of oxygen's retreat, leaving only methane's reign. Yet beauty persists in their dance, a defiant sparkle against encroaching night. How might we adapt, or will we fade like forgotten fish? The bloom pulses on, an enigma wrapped in luminescence. Transition beckons with that distant rumble growing insistent, drawing us inexorably downward. The bioluminescent curtain parts slightly, revealing fissures below spewing the bloom's lifeblood. Gas ascends in thickening columns, carrying whispers of the architects awaiting in the abyss. We've glimpsed the spark. Now the forge reveals itself. Curiosity burns brighter than any glow here. What horrors and wonders craft this toxic symphony? The midwaters release us reluctantly, their lights winking farewell into the void. Life's tenacity shines through, but so does its capacity for the uncanny. Onward into the source where methane's true dominion unfolds. At the bottom of our speculative ocean, where methane gas escapes from fractures in the seabed, there lies a strange and extraordinary world, unlike any ecosystem known to surface life. Here, methane seeps bubble relentlessly, releasing their toxic cargo into the cold, dark water above. But instead of lifelessness, these vents spawn an entire city of creatures adapted to harness the energy locked within this poisonous gas. Vast mats of bacteria cluster around the vents, transforming methane into organic matter through chemosynthesis, the art of life thriving without sunlight. These microbial carpets form the base of a thriving food web, creating a dynamic, bustling landscape beneath the waves. But the fascinating truth is how these microbial mats are not isolated. They serve as habitats and nurseries for a range of unusual creatures that have evolved unique strategies to live off methane's poisonous bounty. What sets this environment apart is that life here is no longer dependent on traditional oxygen-based respiration, but rather on chemical energy unlocked from the Earth's inner heat and gases. Among the most iconic residents of these methane vent ecosystems are giant tube worms, towering pale sentinels that cluster near gas vents like alien skyscrapers. These creatures lack mouths or digestive tracts. Instead, they rely entirely on symbiotic bacteria inside their bodies that convert methane and other chemicals into nutrients they can use. The worms' striking red plumes, packed with hemoglobin, draw in methane and oxygen, channeling these gases to their internal partners. Around them, colonies of mussels and clams form dense beds almost like underwater farms, hosting similar bacterial symbionts that feed on the gas. The animals have traded the surface world's reliance on photosynthesis for a subterranean fellowship with microbes. This profound chemical partnership challenges our assumptions about where life can thrive and calls into question the limits traditionally ascribed to it. Could entire complex ecosystems be built on the shifting grounds of chemical energy alone? Complicating this alien ecosystem is the constant presence of gelatinous creatures that drift among the vent plumes, their translucent bodies pulsing faintly with a sickly light. These beings, adapted for life in a world infused with methane, often float like spectral phantoms around the vents. Their bodies contain gas-filled sacs to help them hover effortlessly in the water, navigating through slow-moving clouds of toxic gas. Some of these organisms even appear to be semi-intelligent, showing coordinated movement and responses to chemical cues in the water, which could hint at evolved neural networks quite unlike anything on today's seafloor. It's as if the methane environment has inspired a different form of life, one where survival depends on sensing gas patterns and chemical gradients, a world more about subtle signals than physical prowess. What manner of intelligence could arise in a realm so detached from the senses we know? The environmental conditions are extreme, with water temperatures fluctuating drastically near the vents, from scalding hot to near freezing just centimeters away, and chemical concentrations of methane rivaling those found in industrial settings. This volatility has shaped animals that are robust yet fragile, adapted to the unpredictable pulses of vents erupting in bursts or streams. Life here clings to every bubble, every fragile filament of microbial mat that flourishes where methane and heat meet. Subtle shifts in seepage can cause sudden die-offs or booms, making the ecosystem a patchwork of fleeting opportunity and peril. The methane seeps create biological islands that are isolated by stretches of barren, gasless seafloor, limiting movement and prompting rapid evolutionary divergence. Is this the ocean's crucible for speciation on an accelerated scale, spurred by the gas's deadly volatility? Among the silhouettes dotting this landscape reside venomous worms, their jaws sharp and translucent, feeding on bacterial mats or smaller creatures. Worm towers rise improbably high, constructed by colonies of tube worms living symbiotically with methane-metabolizing bacteria that anchor to the metal-rich sediments formed by vent minerals. These chimneys and towers create vertical habitats, layering ecosystems in 3 dimensions, unlike most ocean floors. Life clusters densely here with spiders, amphipods, and crustaceans adapted for squeezing into the narrowest crevices, scavenging whatever falls from the microbial feast above. Every creature seems touched by the environment's eerie chemistry and hostile beauty. Despite the toxicity around them, these organisms construct intricate communities, almost architectural marvels of evolutionary innovation. How do these creatures perceive their world, illuminated only by faint luminescence and chemical traces? Scientists speculate that the symbiosis of methane-metabolizing microbes and their animal hosts represents one of the most sophisticated chemical partnerships on Earth, possibly rivaling the complexity of coral reefs in the sunlit ocean. This biotic interplay creates a living filter, recycling methane into biomass that supports the higher layers of plumbing in the food web. Some animals, such as certain bivalves, may even manipulate vent flow and microbial mats to create microhabitats suited to their survival. The delicate balance between vent activity, microbial growth, and animal colonization forms a fragile ecosystem in constant flux, driving cycles of birth and decay at an almost alien pace. Observing this dynamic interaction reminds us that ecosystems can flourish in conditions once thought relentlessly hostile. Could such symbioses be the blueprints for life on other methane-rich worlds beyond Earth? But there is a subtle, almost unsettling aspect to these methane vent ecosystems. While life flourishes, it remains fragile and ephemeral. Changes beneath the seabed can shut vents down abruptly, turning a thriving metropolis into a dead zone in days. The animals must either migrate, adapt quickly, or perish, caught in nature's relentless gamble. Some speculate that these ecosystems flicker to life and vanish on geological timescales, their rise and fall echoing the planet's tectonic rhythms and volcanic breaths. Their mysterious persistence hints at evolutionary lessons about resilience and temporality, reminding us that life, no matter how alien, must constantly negotiate with its physical world. Will humanity's environmental recklessness accelerate or doom such fragile oases in our future seas? With every new discovery, the methane seep ecosystems rewrite our understanding of oceanic life's breadth and adaptability. They beckon us to peer deeper into the abyss, a place where chemistry fuels cycles of strange alliances and survival strategies, beyond the comforting light of the sun. They pose haunting questions about life's origins, potential futures, and even our place in the universe. If life on Earth thrives through such unorthodox methods, what other forms might exist where oceans conceal even more profound mysteries? The methane vent cities beneath the waves invite us to imagine a world transformed, a future ocean both beautiful and toxic, alive with secrets waiting for our curiosity to unlock. How will our legacy be remembered in these depths, under the shadow of gas clouds and their glowing inhabitants? The methane-rich layers within future ocean clouds are not just mysterious havens for life, but spaces filled with elusive predators, evolving in a silent, ghostly game of survival. These predators don't rely on traditional sight or speed to hunt. Instead, they glide stealthily through the dense methane plumes with ribbon-like bodies that shimmer faintly, as if woven from mist and bioluminescent silk. Their movements are eerily graceful and almost hypnotic, like phantoms drifting through an otherworldly fog. In these toxic clouds, where oxygen is scarce and visibility minimal, evolution has rewritten the rules. Eyes have become useless and eventually disappeared, replaced by advanced electric and chemical senses that can detect the tiniest vibrations or chemical changes. These creatures inhale methane-rich water, filtering it through their bodies not just for nourishment, but also as a way to locate clinging prey hidden within the misty depths. How strange it is that an environment so hostile should give rise to such surreal, elusive hunters, capable of sensing the world through senses alien to us. Floating in this dense haze, these predators dance on the edge of visibility, often vanishing as suddenly as they appear, forcing us to question what it really means to be a hunter in such a world. Their pale, semi-translucent skin emits faint hints of blue light, a ghostly glow that flickers unpredictably, suggesting biological processes still tied to light, even in perpetual darkness. These undulating forms slip through methane-rich waters, using currents and their own subtle pushes to advance without disturbing their environment. The predator's hunting method is unique. They don't chase but instead patiently filter immense quantities of gas-laden water, trapping microorganisms and smaller prey within finely tuned internal filters. In this reverse of the usual predator-prey dynamics, food is scarce yet abundant, hidden within the poisonous fog that dominates this realm. How did such a specialized, ineffable hunting strategy emerge? And what evolutionary pressures sculpted these ghostly filters that double as both breathing apparatus and weapon? The methane clouds are more than just physical barriers. They form chemical labyrinths where predators must constantly navigate dangers both internal and external. Methane itself is a toxin to many, yet here it is both shield and sustenance. These creatures have evolved specialized skin membranes that convert methane to energy, a bizarre form of respiration that defies oxygen's ancient dominance. But methane changes everything. It muffles sound, it slows movement, and it simulates a world vibrating on a different frequency. The predators have adapted to this altered physics, developing high sensitivity to slight electrical fields, chemical signatures, and even minuscule pressure waves generated by moving prey. The hunting is a silent ballet, performed in darkness and poison, under conditions that challenge even the hardiest ocean dwellers. Might such adaptations be a preview of life on other methane-rich worlds beyond our own, unseen yet brimming with life? These phantom creatures evoke a chilling kind of elegance, a ballet danced in slow motion, where each flicker of bioluminescence signals a hidden communication or a warning. The predators are not mindless hunters but likely participate in complex social behaviors, using flickers and flashes that ripple through the methane haze to coordinate movements or establish territories. Much remains unknown about their intelligence. Could these subtle light patterns represent language, or perhaps a form of learned behavior? In an ecosystem so new and alien, questions arise about how advanced life might evolve under the constraints of methane-fueled metabolisms. What kind of brains and nervous systems could develop when traditional stimuli like light and sound barely exist? These are not mere creatures of survival but possible pioneers of a distinct evolutionary path that twists familiar biology into something profoundly strange. The eerie blue glow and ghostly motions of these cloud predators contrast sharply with the chaotic energy of the methane blooms they inhabit. These blooms expand and contract with the rise and fall of methane seepages, creating shifting landscapes of life and death. The hunters thrive on these changes, moving like shadows between blooms, adapting their strategies to the ever-changing chemical weather. The methane clouds themselves behave like living organisms, breathing, pulsing, and sometimes collapsing, forcing creatures within to evolve quick reflexes and resilience. This constant volatility sharpens evolutionary edges, favoring predators capable of clever adaptation and subtle patience. As methane invades ever larger swaths of the ocean, could these hunters spread their ghostly dominion, shaping the future ocean's food web? Despite the seeming alien nature of these predators, their existence tells a story as old as evolution itself. Life is relentless, inventive, and endlessly adaptive. These creatures remind us that life can flourish in the shadows of toxicity, using poison not only to survive but to dominate. Their quiet, haunting presence challenges our perception of what it means to be alive and to hunt in a world hostile to oxygen. The slow, shimmering glide of their bodies through methane clouds seems almost spectral, a haunting vision of life that defies human expectations. What mysteries do their movements conceal? Could new senses, non-existent in humans, form the basis for understanding their world? There is a growing sense that the methane-rich future ocean will not only be a place of eerie beauty but also of quiet terror. These predators, often invisible except for a faint phosphorescence, represent a vision of evolution at its most mysterious and alien. Their existence pushes the boundaries of our understanding of biological possibility. We find ourselves wondering, how do these creatures reproduce, communicate, or raise their young in such an unforgiving milieu? What predators, if any, hunt them in this shadowy realm? The questions multiply, deepening the mystery and beckoning further exploration into methane's dominion below. As the methane clouds slowly drift upward, carrying these ghost hunters with them, the story expands beyond the deep. These predators mark the start of a new ecological order, one where chemistry, adaptation, and survival narrate life's enduring tale. They remind us that nature's resilience is sometimes strangest when steeped in silence and toxicity, where shadow reigns and light is a whisper. In this future ocean, the line between life and poison blurs, and predators become phantasms drifting through a toxic dream. What secrets will the methane clouds reveal to those brave enough to peer inside? What horrors and wonders await beneath the gas, waiting to be understood? Rising from the shadowy depths, we emerge into a surface reborn under a sickly yellow sky, where methane bubbles erupt violently, igniting chaotic storms of lightning that crackle across the horizon. The ocean's skin churns with frothy violence as gas plumes breach the air, transforming the boundary between sea and sky into a volatile cauldron. Plankton here have evolved reflective shells, iridescent armor that captures fleeting sunlight and traps methane molecules in a delicate, shimmering dance. These tiny architects float in vast films, creating optical illusions where sky mirrors ocean in endless, hypnotic loops. Atmospheric feedback loops amplify the turmoil, with warming waters releasing more gas in a self-perpetuating cycle of climate frenzy. Life persists amid the fury, exploiting danger as opportunity in ways that defy comprehension. What drives these plankton to thrive on the edge of annihilation? Could this be nature's defiant response to a planet unraveling at its seams? The surface now pulses with a living mosaic of these adapted plankton, their shells refracting light into ghostly rainbows that pierce the stormy haze. Each particle acts as a microprism, bending rays to fuel faint photosynthesis while sequestering gas that would otherwise fuel catastrophe. Beneath the waves, they form vast, undulating sheets that rise and fall with the tides, breathing methane into biomass. Storms rage above, lightning forking like veins of electric fire. Yet these organisms endure, their glow a subtle rebellion against the chaos. The air thickens with ionized particles, creating aurora-like displays that blur day into eternal twilight. Emotional awe mixes with dread at the spectacle of resilience born from ruin. How do such fragile forms withstand tempests that shatter stone? Might they hold the key to stabilizing a world teetering on toxicity? Deeper into this reborn interface, horror subtly creeps as the plankton films harbor unseen predators drawn to the gas-rich bounty. Schools of translucent fish dart through the shimmering layers, their scales mimicking the plankton's gleam to lure prey. Methane saturation alters buoyancy, allowing massive blooms to hover like levitating clouds, defying gravity's pull. The atmosphere interacts viciously, winds whipping bubbles into froth that rains back down, recycling gas in endless loops. Plankton respond by clustering tighter, their collective shell mosaic forming armored rafts that withstand the onslaught. This is evolution accelerated, where survival hinges on light-trapping ingenuity amid perpetual storm. What intelligence flickers in these synchronized swarms? Do they sense the gathering cataclysm, adapting in silent anticipation? The interplay between ocean and air manifests in dramatic feedback, where methane escape warms the planet further, thawing permafrost and seabed clathrates in vicious escalation. Plankton shells evolve nanostructures, channeling lightning static into bioelectric pulses that stun competitors. Vast sheets span horizons, visible from space as glowing scars on a fevered Earth. Beneath, currents carry nutrient plumes upward, fueling explosive growth that chokes clearer waters. The surface ecosystem shifts from oxygen-dominant to methane-tolerant, rewriting marine food chains overnight. Awe swells at life's pivot, yet unease lingers in the storm's relentless roar. How far will this transformation spread before balance fractures completely? Could humanity witness the ocean's vengeful rebirth? Emotional undercurrents surge as we witness plankton not as victims but as vanguard of a new era, their reflective domains turning peril into power. Shells incorporate metal traces from upwelled vents, enhancing durability against acidic rains born of excess CO2. Blooms migrate with storms, seeding distant shores with resilient spores that colonize beaches in ghostly tides. Lightning strikes ignite surface methane, brief fireballs illuminating the plankton's defiant sparkle below. The boundary layer thickens, a liminal zone where physics bends under chemical onslaught. Questions haunt. Are these films stabilizing climate or accelerating doom through unchecked growth? What mysteries unfold in their iridescent depths, whispering of futures unforeseen? As storms subside momentarily, the surface reveals intricate patterns, fractal mosaics of plankton rafts pulsing in unison like a vast, breathing organism. They filter atmosphere directly, absorbing methane that plumes skyward only to condense back enriched. Symbiotic bacteria within shells oxidize gas, releasing heat that warms local waters, drawing more life upward. Optical tricks create mirages of inverted worlds, sky plunging into sea in infinite regression. This reborn surface challenges perceptions, blending horror of instability with beauty of adaptation. Life dances on fire's edge, turning toxicity into tapestry. How might such ingenuity inspire our own survival strategies? Will the ocean's mirror reflect our downfall or redemption? The relentless methane ascent forges a horizon of faint, unnatural lights, where plankton films glow like molten glass under wave crests. Distant silhouettes hint at larger evolutions. Leviathans grazing the luminous sheets, their forms shrouded in mist. Atmospheric loops tighten, promising global shifts as gas alters weather patterns worldwide. Plankton dominate, outcompeting relics of oxygen eras in a silent coup. Mild horror grips at the thought of seas homogenized by haze, skies forever jaundiced. Yet wonder prevails in their shimmering persistence, a testament to evolution's cunning. What tales do these lights tell of planetary fever? Could they herald an age where life masters its poison? Transition draws near as horizon lights beckon, pulling us toward enigmatic flickers beneath glassy waves. The surface's fiery rebirth yields to deeper mysteries, where methane's legacy unfolds in submerged realms. Plankton rafts part reluctantly, revealing currents laced with promise and peril. We've glimpsed adaptation's pinnacle amid chaos, now chasing its echoes below. Curiosity ignites brighter than any storm. What wonders await in glowing abysses? The ocean whispers onward, its reborn face a mask over secrets profound. Life endures, transforms, haunts the thresholds of known and unknown. The last bastions of oxygen-breathing life in a future ocean dominated by methane blooms stand isolated and fragile, tucked away where conditions remain less hostile. These pockets of survival might exist where currents bring fleeting breaths of life-giving oxygen or where geothermal activity moderates the harsh chemistry. However, the widespread oxidation of methane consumes oxygen and produces carbon dioxide, which acidifies the water, creating increasingly hostile conditions for most familiar marine life. Acidification strips shells from shellfish and impairs coral skeletons, destabilizing the ecosystems that once thrived on sunlight and oxygen. The dark irony is that while methane supports new life forms, it simultaneously drives a slow suffocation and transformation of the old biosphere. Can the resilient survivors in these refuges adapt fast enough, or are they destined to become relics of a vanishing era? In this chemically evolving world, the effects resonate deeply across marine communities, shifting food webs and ecosystem functions. Oxygen depletion zones, fueled by microbial methane oxidation, expand, creating vast dead zones where fish and other mobile species retreat or perish. The resulting hypoxia favors anaerobic and methane-dependent microorganisms, tipping the balance toward ecosystems structured by chemical energy rather than sunlight. This shift precipitates dramatic losses in biodiversity. As species unable to tolerate low oxygen, acidic waters vanish. Yet, within this grim picture, new communities rise, life turning to methane as both a resource and a hazard. Does this mean a future ocean ruled by chemistry and toxicity instead of light and oxygen? Such transformations deepen the uncertainty and eerie beauty of this new marine world. Subtle horror underpins these changes, especially when we consider the accelerating pace at which methane release impacts ocean chemistry. As warming waters thaw methane-rich permafrost and destabilize methane hydrates on the seafloor, more gas escapes into the water column. Microbes quickly oxidize much of this methane, contributing to localized acidification hotspots where pH drops far below current oceanic averages. Such acidified waters become inhospitable to calcifying organisms, triggering cascading collapses of reefs and sedimentary habitats. The combination of acidification and oxygen depletion creates a brutal double stress, a chemical squeeze that challenges life's persistence. How will entire marine systems adapt or fail under these compounded pressures? This looming threat paints a grim future but also beckons deeper exploration and understanding. Amid this chemical turmoil, methane-fueled microbial communities emerge as key players, recycling methane into biomass but also altering oceanic pH and oxygen levels. These microbes, thriving at methane seep sites and throughout the water column, represent both a sink for methane and a driver of local acidification. Their activity transforms the chemistry of the water, amplifying hypoxia and fostering environments hostile to many species. The delicate balance between methane consumption and its chemical byproducts dictates regional ecosystem health. Could these microbial assemblages serve as early indicators of irreversible regime shifts? Monitoring their dynamics may be critical in predicting and mitigating methane's cascading ecological effects. Ocean acidification amplified by methane oxidation represents a profound challenge for the resilience of marine ecosystems. Creatures reliant on calcium carbonate, including corals, shellfish, and many plankton species, face challenges in building and maintaining their skeletons and shells. Weakening exoskeletons lead to higher vulnerability to predation and disease, threatening entire food webs dependent on these foundational species. These changes ripple through marine communities, altering predator-prey relationships and nutrient cycles. Could this weakening of marine frameworks destabilize fisheries and human coastal economies? The intersection of methane-driven acidification with global warming creates a perfect storm for ecological and socio-economic disruption. The expansion of hypoxic zones also has troubling consequences for the broader oceanic environment, including decreased fishery yields and shifts in species distributions. Fish and shellfish populations retreat from oxygen-starved bottom waters, forcing migrations to new, sometimes unsuitable, habitats. This displacement disrupts centuries-old ecological balances, impacting biodiversity and the productivity of marine ecosystems. Those regions that can no longer support traditional fisheries may see cascading social and economic impacts for dependent human communities. Will humanity's reliance on ocean resources withstand such upheavals? The story of methane's oceanic rise is also a human story, filled with uncertainty and urgency. Long-term ecological consequences of methane-induced chemical changes suggest a planet increasingly dominated by novel, methane-adapted life forms. Ecosystem regime shifts could become permanent, with current species replaced by communities structured around methane metabolism. This transformation may rewrite oceanic carbon cycling and feedback loops, influencing global climate trajectories. Yet, within this grim transition lies the potential for new evolutionary narratives of adaptation and persistence in chemically altered seas. Could this microbial and methane-driven ocean be an early glimpse of broader planetary-scale changes? It beckons us to ponder the resilience and adaptability of life on Earth in the face of rapid and profound change. Ultimately, the future ocean shaped by methane blooms and chemical upheaval challenges our deepest assumptions about life's boundaries and tenacity. It is an ocean at once mesmerizing and terrifying, where biochemistry writes new rules and species adapt or vanish in shadows of toxicity. Warming, acidification, and dwindling oxygen form a triad that tests the limits of marine survival. Yet, amid the unfolding crisis, life's resilience and inventiveness shine, a faint but persistent glow amid the encroaching dark. How will this saga end? Will humanity rise with insight and stewardship, or falter beneath the weight of its own impact? The methanated ocean is not just a future possibility. It is a stark mirror held to our present choices.